Hi, my name is Temple.
And I'm Forever.
And we are doing the resonance experiment.
Okay, first we're going to talk about the materials you need. You need a meter stick to measure the length of the air column and the diameter of the
air column.
Then you need a graduated cylinder. You need 3 different tuning forks with 3 different frequencies. And we have 256, 392, and 523. You also need a rubber triangle, and you also need to fill up your graduated cylinder to the top with water.
Like this. Our diameter of the tube is 6.5. The temperature of our room right now is 25 degrees Celsius, and our theoretical speed of sound is 346.5 meters per second. After you calculate the theoretical speed of sound of air, you calculate the wavelength, which equals 4 times L plus 0.4 times D. L is the length of the air column, which is the distance from the water at the top of the tube, and D is the inside diameter of the cylinder. So our equation would be 4 parentheses 45.5 plus 0.4 times 6.5, which equals to 0.824. After you do that, you calculate the experimental speed of sound, which equals wavelength times frequency. So our wavelength was 0.824. Then you times that by 493.9, which equals 406.97. After you do that, you do the analysis of speed of sound, which equals relative error equals 100 times the theoretical value minus the experimental value, the absolute value of these.
Over the theoretical.
Yeah. And ours was 100 times 346.5 minus 406.97 divided by 346.5, which equaled negative 98.9. But since it's the absolute value, we will make it to a positive 98.9. So we're going to show you how this experiment goes. So we're going to tap it on this, and we're going to raise this up. And it makes a noise. It has a pitch.
All right, and then that means the higher the frequency, the shorter the wavelength. Also, the shorter the air column length.
This was the 256 frequency. Now we're going to do it with the 392 frequency. Okay. And now with the 523.2 frequency. So that shows how the shorter the frequency, the longer the wavelength.